Hi. Now that we've looked at the rock forming minerals that we need to know for GCSE geology, it's time to have a look at the other minerals that are on the list of 10 that you need to know. We're working on page 9 of your Theme 3 booklet. So, if we have a look at these remaining 5 minerals, these are the ones, you'll find them at the bottom of the table. These minerals are made of a variety of different elements and put together in different ways. They do have one thing in common, and that's that they're all useful. All of these minerals have a value and a use beyond them just being found within rocks. We'll have a look at what that is in a moment. But again, these 5 minerals are ones you need to be able to identify. You could be given specimens of these in your practical exam. You could be given descriptions of them in a theory exam. So we need to be able to recognise them. What I'd like you to do is, as we go through the properties, I'd like you to highlight the ones that are really important, the ones that help you identify these minerals. There may be some additional ones that you can add on the right hand side of the table for each of these minerals. Let me show you what these minerals look like.
These are the other minerals. These minerals form in different ways, and they tell us different things about the environment in which we find them. Each of them has a distinctive set of properties. This mineral is halite. Halite, or rock salt, can be a number of different colours. White, colourless, this one is this orangey brown colour, depending on what impurities are in there. This can grow in cubic crystals. It also has a cubic cleavage, 3 planes at 90 degrees, although neither of those properties can be seen in this particular mineral. This specimen, though, does share some properties with all the halites. It's very soft, has a hardness of 2.5, so it's about the same as a fingernail. It's soluble, so it'll dissolve in water, and you can feel that either by holding it in your hand, and it feels greasy and slippery after a little while, or licking it, when it has that very distinctive salty taste. This mineral is calcite. Calcite is quite a common mineral. It's the mineral that makes up rocks like limestone, or marble, or chalk. It's very commonly found in shells of organisms, and it's a very, very distinctive mineral. You can see from this specimen the rhombic cleavage and rhombic crystals that form. Each of these surfaces at 60 degrees to the other. As well as its cleavage, it has distinctive hardness. It's a hardness of 3, so it's harder than a fingernail, but softer than a coin. But perhaps the most distinctive property of all the ones to choose from for calcite is its reaction with acid. If you drop some dilute hydrochloric acid on this mineral, it will fizz. Our next mineral is this. This is hematite. Hematite is a very useful mineral. It's the main ore of iron. So that by ore, that's the mineral that we use to extract valuable metals. So hematite is quite distinctive stuff. Its colour can vary. It can be grey, it can be red, or even perhaps a mixture of the two, as we can see in this specimen. But there is one very distinctive feature that we see in hematite. No matter what form it's grown, no matter what colour the mineral is, it will always have a distinctive cherry red streak. Even its lustre can vary, all the way from metallic down to dull. This mineral is galena. This is another ore mineral. This is an ore mineral of lead. Now, galena is very distinctive stuff. You can see it has a very obvious metallic lustre. It also has a cubic cleavage. 3 really good cleavage planes at 90 degrees to each other, so this mineral will break up into cube shapes. Not only that, the streak of this mineral is quite a distinctive lead grey streak. It also has a very high density. The density of galena is about 7.5. What that means is the weight of that specimen is about 3 times the weight of that specimen, even though they're about the same size. Galena is also a very soft mineral. Hardness of 2.5, so it's about the same as a fingernail and certainly softer than a coin. The last mineral we need to be able to recognise is this. This is garnet. Now, garnet is a metamorphic mineral. This grows in metamorphic rocks at reasonably high temperatures. It grows into quite distinctive 12-sided crystal shapes. Each of those crystal shapes is, or sides then, is the shape of a rhombus. In terms of its physical properties, the key feature of garnet is its hardness. This is the hardest mineral we look at, even a little bit harder than quartz. It has a distinctive, very dark, reddy brown colour. Each of these minerals forms in a different way. By understanding what minerals they are, we can then interpret the messages, the information about how they form into looking at the wider geological context, and also looking at the value of them. All of those minerals have a value. They all have uses, whether it's to make table salt, toothpaste, iron or steel, lead for batteries or roofs, or in the case of garnet, to use as an abrasive, or even as a semi-precious stone in jewellery.
Okay, so let's have a look at what we've just seen and try and bring it all together. Our first mineral is halite. The key property of halite is its salty taste. It's soluble in water, it'll dissolve on your tongue, and we get a very distinctive salty taste. Calcite has a number of different properties that make it readily identifiable. It has a hardness of 3, so it's harder than a fingernail, it's softer than a coin. It's got this distinctive rhombohedral cleavage, and perhaps most reliably of all, if we drop some hydrochloric acid on it, it will fizz. Even if we can't see or test the other properties, it will always fizz with acid. Hematite, which is an iron ore mineral, Can vary in colour. It's quite hard. It's about the same hardness as a knife or a nail. Its colour though can vary. Its lustre can vary. Doesn't show any distinctive cleavage, but it'll always show that reddy brown, that sort of cherry red streak. Galena, which is lead ore, is very distinctive. It's very soft, softer than a copper coin. It's got a grey, lead grey streak. It has cubic cleavage, and it feels really dense. It's a very dense mineral, Galena, density of about 7.5. And finally, one of my favourites is garnet. Garnet is distinctively hard. It has this deep reddy brown type colour, and when it grows over a long period of time in a metamorphic rock, it can form very distinctive 12-sided crystals. It's also the hardest mineral that we will come across in your GCSE exams. Okay. So, to summarise, each of these 10 minerals that we've seen that are on your GCSE course specification have a distinctive set of properties. Now, you don't need to learn these properties off by heart. You'll always have a mineral data table to refer to when we're identifying these minerals. But it's really important to be able to recognise which the key identifying features of these minerals are, and then how we can test for them. Remember, it won't just be in a description that you get these properties. You could just be given a lump of the mineral, some testing kit, and asked to do that in a practical exam. So next time we need to think about how we actually go about making our decisions about identifying minerals. I'll see you then.